Hello, my name is Ethan Vosberg, and I want to give you a quick presentation on how to make a solenoid and just walk through some of the steps and considerations when making a solenoid. This is specifically for the Circuits 3 level class at Cal Poly, but it could be applied to any situation. So let's get right into it. First, let's discuss on how to make a solenoid. So just quick refresher from physics is a solenoid is just an electromagnet with a ferrous core that when you apply a current to that electromagnet, that core is able to move. And so that kind of, I tell a lot of people who I'm introducing a solenoid to, it's basically just a linear motor. So you can just have this, in our case, it'd be a nail, a ferrous nail, that's able to pop in and pop out. And you can do a lot of cool things with it. So in this case, the purpose of this solenoid is to lock and unlock a door. So you can imagine that if that solenoid were to pop out a nail, you could actually block the opening of a door. And then the same, you could pop it back in and unlock that door. And so that's the idea of the solenoid. In terms of the parts that you need, it's a pretty straightforward project. You need some kind of way to hold that ferrous core loosely so it's able to be affected by that electromagnetic field. You also need a way to spool the wire around it. So we'll discuss exactly what this wire is, but we'll be using a wire to form that electromagnet. And then beyond that, just a way to kind of hold everything together. So we'll discuss that. But first, I want to go ahead and walk through the design. So let's take a look at what exactly I ended up going with. So I chose to use Fusion 360 to design my source. You can see right here that we have two parts. We kind of have this main spool, which is highlighted right there. And then we have this spindle holder, which is highlighted right there. Let's go ahead and first look at this spool. So the spool can really be just as simple as kind of this barbell looking thing. Let's go ahead and just take a look around it. So you can see that we have this through hole that that's where the nail ends up going, or whatever ferrous core you choose. And then right here we just have this spool profile that we are able to wind around. This is the important part, making sure we have these caps right here so that wire does not come off. You could theoretically just use a cylinder, but it wouldn't go that great, and this just gives you a lot of extra help. A couple noticeable things that I added on mine. So you see I have a hole right here, kind of zoom in. This is to allow that wire to go through. I would say this is more of an optional feature. It's definitely not necessary. You can just have the wire kind of come out. One thing that I would highly recommend though is actually this slot right here. And the reason why that's nice is because it allows you to index what I called the spindle holder, and that allows you to actually put this onto a drill and then rotate the spool so you can actually wind up the copper wire, which is just a huge help when you're assembling. And so with that design kind of out of the way, let's quickly talk about how to get these measurements. So with this, I kind of just ballparked. I was taking a ruler. I was like, oh, probably 20 millimeters or 25 millimeters looks good. And then I said, hey, maybe like a 30 millimeter circle looks good. And all those little things. So that was just kind of ballparking. The one thing that is critical is this inner dimension. You want it to be like about half a millimeter more, half a millimeter to a millimeter more than your diameter of your nail or whatever core you have. And that just allows it to slide easily. Let's talk about getting the parts now. So there's a couple parts that you want. We can kind of go through those now, but the two main parts that I was using is, other than the 3D printed stuff, which for 3D printing, I'll discuss this in a sec, but there's places on campus where you can go to get them. But the big one is magnet wire, or some people just call it copper wire. But this has just a thin enamel around it. It basically allows the coil not to be a short circuit. And then it also allows you to tightly pack your windings. And in terms of windings, you just kind of want to go until you've saturated your core, or you can go, I ended up going about halfway I don't have a firm number for the length, but you just kind of go until you get like a good piece of winding on there. I want the 24 gauge magnet wire. You can order this from Amazon. Just look up 24 gauge magnet wire, or IEEE might have it as well. And the other thing was electrical tape. So after winding, I just took some electrical tape and really tightly wound that around the solenoid. And that was kind of the important parts right there. But yeah, it's pretty straightforward. And then when you finally get to assembly, what you're gonna do is you're gonna go ahead and you can kind of see with our solenoid, we tightly wound it around that core. And then we put that electrical tape on, and then we have our 2 wires kind of going out into our circuit. Couple notes when 3D printing. So let's go ahead and look at the 3D printing really quick. So here was the configuration for 3D printing that I went with. I chose to have the spool standing upwards like this and the spindle holder to go like this. For a couple reasons, this means that my inner dimension for that hole that's going to hold the actual core, that's going to be a lot more accurate if I print it upwards like that. And then for the spindle holder, I prioritized strength over accuracy. So you can print it laying down like this, and you'll see the layer lines are going to end up being vertical or kind of horizontal along it, which you'll sacrifice some of the dimensions for, but you can just use some sandpaper to quickly sand that. And then once you have that, it'll kind of register in. And then one other thing that I would highly recommend is you'll see right here, I have 3 layers kind of in this part right here. And I would highly recommend 2 or 3 layers in there. So just make it thick enough that you can get 3 layers in there. And I think I ended up going with about 0.6 millimeters. You could go to just 1 millimeter and just to be safe. But the thinner that is, the stronger the magnet will be. So that's a trade-off that you might need to make. And then I printed it standing up like this, so that dimensional accuracy was there. And the bottom surface, so when we get to the bottom surface, so all the way up here, that's going to be a little bit rougher, but I don't care. That's a sacrifice that I'm willing to make for that accuracy. Yeah, so that's kind of the finished product right there. So yeah, that was how I ended up making the solenoid. Obviously, this is just a starting point. There's so many other ways to take this, and I would highly encourage you to get creative and not do what I did, but find a better way to do it, more efficient way to do it, more a stronger way. There's tons of resources on campus. So the IEEE lab does have magnet wire, and they have sandpaper right next to it too. So right after you do it, you can sand off that enamel, and you'll be good to go. And then also there's a ton of makers places on campus that have 3D printers that you can use. And once you can ask someone to 3D print it. I ended up 3D printing. I own a 3D printer, so I lucked out there. But maybe a classmate of yours has a 3D printer. You can ask them to use it. It's a super fast, super small part, and so it really takes almost no filament. I would highly recommend PLA should be just fine. I used PETG. I like that more. It was a little bit better for heat since this can heat up. But if you're just using this for a presentation, it should be perfectly fine. And yeah, so that was my final notes. I hope you enjoyed, and my email is right here if you have any questions, or I'm sure your professor could also get in contact with me. Thank you.